Alright, so what I wanted to talk about today was really some of the successes and challenges of AI that we've seen. Oh, there's a clicker even, awesome. Yeah, some of the successes and challenges we've seen in AI in the past decade. So in particular, I think it's a really exciting time for AI because finally there are so many new applications that are making their way to interacting with users. So that's why I called this talk AI in the wild. So it's now interacting with people, and so what are some of the maybe limitations? And so I want to talk about the hype around all of AI, but also talk about the limitations so that we're aware of what they can do, what these systems can do, and maybe what's more challenging. Let's see if the clicker works. Oh, yeah. Okay, so just as maybe a quick retrospective of some of the high-profile successes of AI over the past decade or so. So here's one example, so with Jeopardy. So we have the system that is able to retrieve and find the relevant information to solve a particular Jeopardy clue. And so it beat some of the top human players like Ken Jennings. So that was interesting. Yeah, and then next, more recently we've had success in the AI community with Go. So originally with the big breakthrough, it was by this system that used a kind of machine learning called deep reinforcement learning. So it was able to learn patterns based on previous games played by Go experts, by human Go experts. And it was trained to figure out what are good moves to take in certain board positions. And then it was able to then take all of that and beat some of the top Go players in the world. And then a few years after that, what they found was that you don't actually even need these human expert playthroughs. Instead, you can have a system that's designed to just play against itself, and it keeps repeatedly playing against itself millions of times to get better and better and better, all on its own. And then based on that, it was even able to outperform the previous system trained on human playthroughs. And that was a massive success story. Okay, and then, in fact, one of the human players, Lee Sedol, who played against this system and lost in a series of 5 games, he was so upset by this that recently he decided to retire from the Go arena. I guess that he was upset that no matter how good he was, even if he was the best human player, there's still another player out there, like an AI one, that is going to be better. So then what's the point? So maybe that's a more fatalistic view of the future. Okay, and the successes go beyond these maybe somewhat artificial setups of games. Okay, so we also have AI systems that are deployed to users, and you can in fact get it's enabled in your smartphone, some voice assistant, and you can also just get one of these new Amazon Echo or Dot or whatever, or one from another company for $50 Canadian and have it in your home. And it can tell you jokes, it can tell you the weather for tomorrow, it can play music and do all sorts of things, and so that's another success story of AI. Okay, so those were some of the high-profile successes, both in terms of big news-breaking kind of headlines, and also maybe more something that you might interact with in your daily life. But let's also talk about some of the limitations and maybe the hype surrounding all of the new AI technology. Okay, so we have, not yet? Yeah, thanks. Okay, so we have Elon Musk, who backed this company, OpenAI, and then they created this architecture and model that reads massive amounts of language drawn from the web, from the internet, and it learns to patterns in that data, and it can then generate new language and new text. And so then there were all of these headlines a year or two ago about how these new, they're called language models, are so powerful and so dangerous that maybe it's scary. And in fact, on the next slide, there are even headlines that it's too dangerous to be released to humanity and might threaten us all. So I'm not sure if we can get this going with the demo, but actually, if you go to the next slide, so we have the link, you can actually play with this yourself, and I don't know if it's possible to switch to the Chrome window where we have. So they actually, despite all of the scary headlines, they released this so that you can play with it and you can actually generate new text on your own. And so I put in one prompt. Maybe it's not there. So is it possible to put in something like it is cold in Montreal today? Or we can also take a, yeah, let's just do that first. And then it should be generated underneath. So if you scroll down, yeah, we can see what are the outputs and whether it's like reasonable. So I can't actually read it. Yeah, so this is a bit funny. There's some issues with like coherence or repetition. But anyway, this is supposed to be the model that is so terrifying that it can't be released to users. Yeah, so you can see that our technology still has some limitations. So by the way, this is the type of thing I work on. I do like natural language stuff in AI, so I'm all about this type of work. And this type of model actually has improved performance in a lot of benchmark data sets in academia and natural language processing. So it's actually a real advance. But I'm saying that let's look past the hype. We still have a long way to go. Okay, so we can go back to the presentation. Yes, so next slide. Awesome. And then the other kind of limitation is maybe more serious and deadly. So we have self-driving cars, and in the average case, they might even be better than humans if you're driving in ideal conditions on the Google campus or whatever, or the Hoover campus. But then there are these cases recently where these self-driving cars have caused fatal accidents in situations that human drivers would probably not have caused the same kind of accident, because the vehicle acted in a way that's very unlike human behavior. So that's a huge problem, and so what I want to talk about is like, what are some of the characteristics of the tasks where AI currently can do really well at, and what are some of the characteristics of tasks where they can't? Yeah. And so what do we need to, also like if you're also going to all go into the AI industry, what should you watch out for, and like how do you look past some of the hype and see whether something is actually realistic or not? Okay, so next, so what is AI anyway? I'll just spend like very small amount of time to talk about that. So there are all of these terms being thrown around. So here's how I conceptualize AI in various terms that are very commonly used these days. So we have AI overall as a field. And you can have some working definition, which is like it's meant to be algorithms and techniques to produce intelligent behaviors or useful behaviors. And a technical term there is like something called rational, so something that improves some objective. So there may, not yet. So within AI, we have many subfields, and the kind of AI that's getting a lot of attention recently and a lot of this hype is within machine learning. So this is the kind of AI where rather than explicitly telling the system what to do in a situation, you give it examples of what it's supposed to do, and it's supposed to learn how to behave based on that. And within that sub-area of machine learning, then there is something called deep learning, which is what's responsible, partially responsible for like the Go system and all sorts of advances, and like the language model and so forth. But it's one kind of deep machine learning, but there might be other kinds of machine learning, other subfields that also contribute to all of the successes. Okay, so now next slide. Yeah. So what does modern AI actually look like in terms of a deployed system? Well, there's going to be a combination of things. So you do have your awesome deep learning techniques, and to make it work in products and in practice, it's not just going to be like some algorithm on its own in isolation. So first, that algorithm and that learning algorithm has to be applied to a lot of data. So you have to pick the right kinds of data, the right amounts of data that's useful for your domain. And also in deployed applications, usually you have a lot of built-in knowledge about that domain. So for example, in your voice assistant, you usually have lots of rules to make sure that you can have high precision rules that identify particular patterns and match it to particular outcomes. So really, it's in an actual deployed system user, it's not going to be some pure thing that only relies on deep learning on a large amount of data. It's usually going to be some hybrid system where you throw a lot of things together so that they actually work well in practice in the majority of the scenarios. Okay, so, and also just because deep learning has been so influential lately, you might have heard that this year's Turing Award went to Ashok Benjo and colleagues for their contributions to deep learning. And that's one of the major, the reason why we have all of this hype around and successes in AI. So how deep learning works in a very brief nutshell is it's inspired by how a neural network, a biological neural network might work, but only on a very rough level. So if you can think about it, you can also think about it in terms of mathematical computations. So you have some input, maybe you say to your smart assistant, like get me the weather forecast. And you can think of that as first needing to be translated to some numerical representation. And then deep learning involves taking a lot of data in order to learn a function that maps that numerical representation through multiple layers of transformations. And so then you can get multiple layers of real value transformations. And then at the end, you get some final layer where you can interpret the numbers there as some kind of scores or some kind of probabilities, which can then be changed into some label, maybe often a discrete label in the language setting. So, some label that represents the intent of the original request, so then you can make the right API calls and get the right information for your application. Okay, so yeah, as I said, deep learning is very, very useful in certain settings. So in particular, if I were to give like some characteristics of the kinds of tasks where deep learning might work well in, it would be things where you might have, which are more involving well-defined task setups. So for example, maybe spam protection. You have some input, which is a sequence of words in your email, and the output is like a binary classification label of like, is it spam or not? And you are able to get many, many representatives just by crawling your past history of like, if you're an email provider, like a collection of emails which you know are either spam or not spam. Maybe that involves some annotation by humans, but the idea is there are some clear examples. The problem is well defined if you give the annotators the right guidelines, and then you can get representative examples to train these deep learning-based methods. Or another type of task where deep learning should work really well in is maybe in games, where you have well-defined rules and you're able to do this kind of self-play. And so once you know the rules of Go, the environment is perfectly observable and perfectly set up, and then so you can just make lots and lots of runs of game playthroughs and get very high performance. However, there are also limitations to the current methods. So in particular, one big limitation is that they tend to find statistical associations which are not necessarily representative of the underlying reason why a certain sample should be given a certain label, belong to a certain class. So if I can give one example, it could be that, so essentially they're finding a statistical correlation between maybe the word weather and like the API call of like weather report, but that's not, they don't actually understand the entire sentence. They don't understand it's actually a command and so forth. And so then this can cause problems, and we'll see examples of that soon. Okay, so here is one example here. So this is one example where there's people have come up with ways to trick deep learning-based systems. So this is originally a question answering setup. So you have an article and you have a paragraph and you have a question. And in the original setup, there's no blue sentence. And so then the deep learning-based question answering system is able to get the correct answer. If you read the paragraph, you can understand it. But then what these researchers did was they added a distracting sentence which involves similar kinds of words, like similar kinds of numbers and so forth, and names. And then once they do this, they can trick the deep learning-based systems into giving the incorrect answer. So that's kind of scary because this would never happen to people, because people actually read the paragraph and they can understand the context, and they would not be distracted by irrelevant information. Okay, next. Another one, which is one that my lab has worked on at McGill, and Mila, is like involves problems where you need to have contextual or common sense understanding to actually get the correct answer. So the one we worked on is involves pronouns. So you have here we have two contexts. One is like Jim yelled at Kevin because he was upset, or Jim comforted Kevin because he was upset. And the problem is to figure out who he refers to. Is it Jim or Kevin? So these questions come from a data set called the Winograd Schema Challenge. And humans can solve these no problem with like 90% accuracy. So like Jim yelled at Kevin because he was upset, so I guess probably Jim was upset. So we have an understanding of how the world works, so then we can solve these questions. But like systems performance, so for a long time they were roughly random, and recently they've gotten better. But what we were interested in was like, even the systems that do get it right, are they getting it for the right reasons? Okay, so for example, one test we tried was what if you swapped the names? So if you swap the name so that now it's Kevin yelled at Jim rather than Jim yelled at Kevin, then your answer should also switch, because these names are just names that point to entities in the world. It turns out that what we found was that a lot of the current state-of-the-art models, they get really high performance on the original data set using deep learning-based methods, so language model-based methods like that talk-to transformer model. The performance drops substantially when you do this. So that's another case where it's very unhuman-like. And so this is a problem. It's saying that these methods, learning based on statistical correlations, when you actually deploy them, you can expect them to maybe fail in many corner cases because they're not actually understanding the world. Okay, and another major area, I'm running out of time, is in AI fairness. So another example is people have done studies correlating gendered pronouns like he or she with occupations, and they found stereotypical associations there. So that means just learning based on large amounts of text, you're going to find the stereotypical correlations, and you might say, okay, maybe that's okay. That's just how words are distributed because of biases in our society. But if you go to the next slide, this can actually cause problems when you design systems that have an impact on people. So, for example, suppose you have another information retrieval system that tries to retrieve the web pages of students, like computer science students at a university. So because there is this other biased association between, say, male gender or male pronouns, for example, with like computer science students, then an IR system is supposed to retrieve and give you things that are prototypical. So then it might give and rank a web page that has a male name more highly than one that has a female name, and that would not be justified, right? Because then that would kind of be discriminatory because you don't want to like rank and prefer a certain candidate just because of their gender. So what I'm saying there is you need to like be aware and fix and potentially try to fix this, and not doing anything is not a neutral position. Just using statistics and saying because it's objective and statistics it's fair, that's not actually how things work in the world. Okay, so I'll end by talking about some open questions that people in the research community are working on, but that will also have an impact no matter what you do if you work with AI that's deployed. So one is that we need to develop methods that can actually work by understanding the world in a deeper way beyond simple statistical correlation. So I bet those methods will also rely on statistics and deep learning, but maybe we need to inject more of our knowledge about the world into these systems. And the related point is that on the software engineering side, you might need rigorous tests of these methods to actually make sure that if you deploy them, you don't get some disaster where they behave in a very bad way with potentially lethal consequences. A second open question, next slide, is to really try to develop AI systems for social good, or at least not do social harm. And we want to have systems, for example, that make decisions that are more fair and less biased. So what I'm really afraid of is like someone just like wanting to create a startup where, and then they just, without consulting anyone, they take some code from GitHub online for like ranking job applicants, and then they feed in some data, and then they produce some product and they sell it. And I'm really afraid of that. So you can see that, like for example, for this application of like ranking job applicants, there are problems. So if you click, so someone did something like this, and they applied their machine learning based system to some data without really thinking about it. And what that system found, if you read the quote, is they found that the best job applicants most likely to succeed are those whose name is Jared and who played lacrosse in high school. So you can see like statistical correlation is not like representative of how things work in the world, and you have to be very careful, and you need to really talk to your data scientists and your machine learning people when you deploy. Okay, next, finally, and more of a research side is, do we really need more of the same kind of techniques with just more data? Or is it we need some paradigm shifts in AI? So this is a really open question. We don't really know. I don't really know either. So something for researchers to investigate. Okay, so yes, thank you for your attention, and happy to take questions.